Now let's think about a simple harmonic oscillator and initial conditions. So this is often important when solving equations for simple harmonic oscillators. What are my initial conditions? So in another video, I told you that this equation for simple harmonic, motion plus omega squared x equals 0. We looked at a bunch of solutions and non-solutions to this, and two of the ones we proposed were xt equals a cosine omega t and xt equals a sine omega t. Okay, well it seems like these were both good solutions, but what if we know something? What if we know that at t equals 0 we have maximum amplitude? And if you've made the connection, you might have seen this. If not, the a in these equations was the amplitude. So in the solutions and non-solutions in the other video, the a would be the amplitude, that multiplicative constant that they can all be off by. Well, if I have maximum amplitude, that means that I should just get a out. So my initial condition would be at time 0, I should get a. And then I can look and say, well, which one will give me this? If I have time 0, then the argument of the trig function becomes 0. Well, cosine of 0 is 1, and sine of 0 is 0. So this would not be a solution given this initial condition. This, however, a cosine, would be a solution. And we can do the opposite. So given these two possible solutions, the idea here is basically if there's a large set of solutions that all seem to work, how can I differentiate? Messed that up, sorry. How can I differentiate between them? And the answer is to use initial conditions. Or if I'm having trouble figuring out what my solution might even look like, the initial condition can give me some insight. So at t equals 0, we're going to say we have equilibrium, which would mean lowest amplitude. Okay, well, which one of these would give me the lowest amplitude? Or lowest, sorry, I'm conflating two terms there. Lowest position at a certain time. So this one gave me my position was my amplitude, my maximum displacement. This one, I need to give me my position is the smallest it can possibly be. So what would that be? X 0, if we're at the equilibrium position, is 0, so my smallest displacement. And displacement is just, I'm thinking how far I've moved from equilibrium. So if this is my equilibrium, how far I've moved from it. And that answer, as we discussed before, would have to be the sine function. Sine of 0, 0. Cosine of 0 is 1. So here, my solution would be the sine based on my initial conditions.